So welcome to Chapter 2, Part 1. We are going to talk in Chapter 2, we're going to discuss math notation and the order of operations. And then in the second part, we're going to get into NOI and R, noir, but that actually stands for nominal, ordinal, interval, and ratio. And then we'll talk about discrete versus continuous variables. But to start with, let's go ahead and start by doing a review question. So the average IQ of adults in the United States is 100. This is if we're talking about a number of adults in the United States as the population, then this is a parameter. So in all honesty, that is how they do IQ, by the way. IQ stands for intelligence quotient. They make it 100 on purpose, right? So it is 100. The actual average is supposed to be 100. At least traditionally, that was the case. And that is a parameter. So parameter is a number that describes the population. Here we go. We need to talk about something else. What does it mean to measure something? When we say, I'm going to measure the temperature or measure your opinion, what are we really saying? Now, in statistics, we have a kind of a specific definition of what a measurement means. A measurement means to apply a number to something. Okay, so in statistics, when we're measuring, we're applying a number to a variable. That is the measurement, applying a number to a variable. There's a lot of different ways that we can do that, but that's the basic sense, applying a number to a variable. So let's go ahead and measure something. How many cups of coffee have you consumed today? When we measure this, so let's say that the people in this class are the sample, what we would do as researchers is we would collect all the data from all the different people, and we would create a table out of it, a spreadsheet kind of a thing, right? It would be rows, and each row would be a different person, and then each column would be a different variable. So for example, it would look something like this. So here's the different participants. I have Erica and Paulo and Lee and Fuso, right? So Erica consumed 2 cups of coffee. Paulo consumed 0, Lee consumed 3, etc. So the participant, that would be one column, and then the number of cups of coffee, that would be another. Now, let's say that we also measured how many hours of sleep. Now, that would be another column. And then we would give Erica slept for 7 hours and Paulo slept for 6, and that column would have those things, right? So we can have as many columns as we need to, but each row is going to be a different person. So that's how we're going to set up our data in this class. When we do this, we can just number the people, right? So Erica is person number 1 and Paulo is person number 2, etc. In fact, when we're doing experiments and scientific studies, what we do is we do not put people's names because of confidentiality reasons. So instead, you will see something like this. Participant 1 drank 2 cups of coffee. Participant 2 drank 0 cups of coffee. Participant 3 drank 3 cups of coffee. Participant 4 drank 4 cups of coffee. All right, that is how we would do this. This is what you're going to see many times. Now remember, each row is a different person. The number that we put down instead of the name, so Erica is person number 1, that is a measurement, if you want to say, call it a measurement. We've applied a number to a variable. In this case, the variable was the person's name. All right? When we talk about math, we need to discuss mathematical notation. Now, this will be the same as you've had in other classes, I hope. But often when we talk about these things, we talk about X or Y as the variables that we really care about being measured. So for example, when we look at the cups of coffee would be X. All right? X equals cups of coffee. If we had a second variable like hours of sleep, then we would use Y. So X would be cups of coffee, and Y would be numbers of hours of sleep. N is the number of participants, or the number of scores we had. Now remember, we had 4 people, and so we have an N of 4. N is the number of people, the number of participants in the study. It's technically the number of scores, which can be slightly different, but just for yourself and for me, just think about it in terms of the number of participants. N is the number of people in the study. It's 4. Now that does not change if we have 1 or 2 or 3 or 4 variables, right? So if we're measuring cups of coffee and nights of sleep, or hours of sleep, and number of siblings, then we still have an n of 4, right? It's still only 4 people, but we've just measured the different variables. So n is just the number of participants total, the total number. I is the individual, the ith score, the individual score for participant I. So participant number 1, if I equals 1, then Erica is who we're talking about. So if I want to know X when I equals 1, then I want to know the number of cups of coffee for Erica because Erica is the first person. What does this mean? Well, let's do an example with sum. So you see this uppercase sigma right here. When you see this, it means sum. It means add them all together. Okay? This is a sum. So whenever you see this uppercase sigma, we're talking about the sum of whatever the group happens to be. So let's take a look at this, and I'll go through the different notation pieces here. This would be the full amount, like the complicated way of saying, I want you to add up all the numbers of cups of coffee here. So let's kind of go through it. So now the first thing we know is that big sigma is a sum. So we want to add them up. X, in this case, X is the variable cups of coffee. So X is cups of coffee. I, remember, that's the ith individual, right? So I want to know all the cups of, I want to know cups of coffee for the people, the individuals here. And these are the participants, number 1, 2, 3, and 4, all right? So Erica and Paulo and Lee and Fuso, right? Those are the participants. Each I is a different individual. And what's going on here says when I equals 1 at the bottom, but n at the top, that says start with number 1. So at the bottom, start with person number 1, individual number 1, and go to the last person, all of them, all the way to the nth person. So what this is saying is start with person number 1. I equals number 1. That is this first person right here. And then add up all their scores until you get to the last person, until you get to the nth person. Add them all together. So this just says, starting with person 1 and going to the last person available, give me the sum of cups of coffee for each individual. And that would be well, the sum of the cups of coffee would be 2 plus 0 plus 3 plus 4. So 2 plus 0 is 2, plus 3 is 5, plus 4 is 9. So this, the answer to this would be 9. We're just adding them up. It just says add them up. Okay. Technically, you could have different numbers. Instead of I equals 1, I could equal 2. And if I equals 2, and instead of the n at the top, we had a 3, it would look something like this. You'd have the sum sign. Let's see if we can get it to go. Sum sign with 2 on the bottom and 3 at the top. 3. There we go. And then this would be x sub I, like it's supposed to be. That would be, I want the sum starting with person number 2 and ending with person number 3. Okay, so what is the sum starting with person number 2, ending with person number 3? That would be the sum of person number 2. Person number 2 had 0 cups of coffee. Person number 3 had 3 cups of coffee. The sum of person 2 to person 3 is 0 plus 3. It's 3. It's 3. Okay. Conversely, if we had changed this to, let's change that to a 4. Now I want the sum of person 2 through person 4. So I want 0 plus 3 plus 4. that would be 7. Person 2 had 0 cups of coffee, person 3 had 3 cups of coffee, person 4 had 4, and you're telling me to give you the sum from person 2 through person 4. The answer to that would be 7. All right. Normally, in psychology, in statistics in general, we don't go through the process of giving you the bottom and the top. Instead, we just write it like this, the sum of x. And normally we want the sum of everybody, and so we just assume that the default is the sum of everybody. So if you see sigma x, that just means, at least uppercase sigma x, that means I want the sum of everybody in the sample. And if you remember, in ours, that was 9. So those two things are the same. Those two are the same. X bar, you see that little bar on top of the x? X bar is the mean of x. The mean is the average. So X bar is the mean of X. Now remember, X is not the participants, it's the cups of coffee. I want the average cups of coffee. So what is X bar is how we say that. What is the mean of X? The mean of X is 2 plus 0 plus 3 plus 4 divided by the number of people in there. And I should have used a different example number, huh? So 2 plus 0 plus 3 plus 4 equals 9. We already knew that. Divided by 4. Because there's 4 people, we want the mean. We get 2.25. X bar for the sample is 2.25. 2.25. The order of operations. Now, you've known this since middle school, but we need to make sure that you remember. Please excuse my dear Aunt Sally. Or, in other words, parentheses, exponents, multiplication, division, addition, subtraction. Please, please, please do this in order. This is going to be really important because the sum of x squared and the sum of x squared are going to be two different things depending on whether or not there's going to be a parentheses in there. That is going to be really important for us. So here's what I mean by that. Let's see if I have it. No, let's see if I have it right here. So if I've got the sum of x squared and the sum of x in parentheses squared, those are two very different things. Remember, parentheses comes first, then exponents, then multiplication, division, then addition, subtraction. And this big sigma, that's a sum. That means it's addition. Okay? So in this particular case, let's go back to our actual data. The sum of x squared in the first instance means we've got to do the squaring first, and then we add them up. So this first one, the sum of x squared, okay, let's take a look at these right here. The sum of x squared, let's show you right here, sum of x squared. Okay, whoops, there it is. Without any parentheses means we've got to square them first. So first we square 2 squared is 4. 0 squared is 0. 3 squared is 9. 4 squared is 16. We square them first and then we sum them because order of operations. So the sum of x squared equals 4 plus 0 plus 9 plus 16, and that is 29. Make sure, yeah, 29. Okay? But that's different than, in parentheses, sum of x squared. Okay? The parentheses means we start with that first. So in this case, we would take the sum of these and then square it. We already know that the sum of those is 9, so 4 plus 3 plus 0 plus 2 equals 9 squared equals 81. So please remember the order of operations or else we're going to get out very, very confused throughout this entire class. Let's go ahead and end with this question. The average IQ of adults is 100. This is remember? That's right, it's a parameter. It's a parameter because it describes the population.